Hello everyone, this is Suhas Palupuri and Uday Kocherla. We both are going to present our paper based on hyperspectral image classification, which comes under the domain of image processing. So let us start with the abstract of this paper. Actually, the paper is completely based on how deep we can learn in an object. So that is what the concept of hyperspectral imaging. And in this hyperspectral imaging, we can normalize the data pre-processing too. Mainly, the hyperspectral image model itself is used to learn any object in deep manner. So, for suppose, let we take a normal camera and we shot an object. We can study the object for a particular instance. But when we start using this hyperspectral imaging, we can learn about the object into deep. Suppose we take a leaf, and when we start shooting with a normal cam, and when we start capturing with this hyperspectral image camera, we can learn the leaf in a deep manner about its characteristics, about its diseases, and about its defects in a deep manner and with more efficient way rather than a normal rare camera. And let us start with the accuracy, which is comparably more efficient than a normal camera. So, by the way, how can we mean a hyperspectral image? According to the most recent advancements in optics and photonics, the hyperspectral image sensors are much more efficient than a normal lens. A hyperspectral image is nothing but an image which shows the complete information of an object in a deep manner, which we can get the entire data as per 99.9% accuracy with this hyperspectral image. For suppose, let us take the image which we are presenting is a leaf, from which we are characterizing the different layers of a leaf so that we can get the perfect data about its characteristics, about its diseases, and about its normalized features, and we can get a cure or we can get more data for that particular object. So let us start the literature review. By doing a deep review of around 20 papers, we come to know that hyperspectral imaging is nothing but a part of photonics, which gives more accurate value than any other one. So let us start with vector machines and neural networks. So these are the two classifiers which we can classify in an hyperspectral imaging. A large part of this latest work of hyperspectral imaging can classify any object in different manners in different objects. And we can also have so many advantages so that we can reduce our work and we can make our work in more efficient manner with a less time. And moreover, by applying this SVM, a directed picture channel and a procedure for arranging hyperspectral imaging can also be introduced. The directed picture channel is utilized to fuse the spatial highlights into an SVM classifier, where in exactly we can also encode the different type of object classifications in a more efficient manner, which can be understandable by an uneducated person too. We can explain to anyone in a detailed manner and we can show them an accurate results. So this is the main base matter what we have gathered by surveying so many literatures. So let us start with the three dense layers, which can be deep, fully connected neural networks. So which I have shown in the neural network part and which will be uh, explained by my co-author Uday Kocherla.
Thank you, Suhas, for the introduction and literary survey. Myself, Uday Kochalna, I'm now gonna continue with how we're gonna achieve this three dense layer deep fully connected neural network and the working model and the step-by-step procedure and what's the method we're gonna follow in this model. First, we're gonna make use of the data sets of 42,776 hyperspectral images of Pavia University, along with the several bands of the Weebly database repository. And the hyperspectral images are first made use of pre-processing and then made into first normalization, and the exploratory data analysis is done in the hyperspectral images for classification of images, and then the model which we are going to propose is applied to the images to get classes for each pixel. The deeply connected neural network is of three layers, and each layer of namely 3 into dense 128 layer, 3 into dense 164 layer, 3 into dense 32 layer, with each dense layer followed by dropout of insignificant feature. Every layer after passing images through every layer, we're gonna follow some dropout and giving the most precise accurate data, final data. And this data is compared along with the data which we are going to classify using the pre-existing classifiers, namely logistic regression data classification model, svm data classification model, and decision tree classification model, which will give precision, accuracy, and some F1 score, and giving the final accuracy of the proposed deep fully connected neural network model. First, this is some of the performance matrices of existing and data models, and we can see that when the leaf is split, that means somewhat crumbled and diseased, then CV that precision is 0.81 and recall is 0.91, giving the F1 score of a harmonic ratio of precision and recall, and giving the overall accuracy of 0.82. When the leaf is healthy, that means that's giving very good high precision, high recall value, giving the harmonic ratio of precision recall F1 score of 0.94, and giving the high accuracy value. That we can observe from this matrices that whenever the precision recall and accuracy are high, that means model neural network model is giving the accurate value that the leaf is very healthy. And when the values are very low and pretty low, then we can understand that leaf was not in a healthy condition. And this is a flowchart or a explanation model of how we're going to achieve this data processing and image processing. First we're going to input data, then with the data pre-processing we can form the batch normalization, followed by 3 into dense 128 group, and after that we'll be followed of some insignificant features, and later that after dropout of insignificant feature, we're going to feed that data into 3 into dense 164 model layer, and then also followed by some dropouts, and then that was followed by 3 into dense 32 model layer. Then there is final, and we'll get most optimized data dense layer, and then we're gonna classify it according to our need. And this is how we're gonna calculate the precision and accuracy and the overall F1 score. First the data set, then pre-processing, and splitting and training and testing, which was and then we'll follow two parts. One is existing classifiers like logistics, SVM, decision trees, and the model which we have proposed is we're gonna see how this works, and following three dense layers and optimizations and classifications and all this, we're gonna get two outputs. One is from our proposed model, and one is from existing classifiers, which we're gonna see, which we're gonna finally calculate the comparisons, accuracy, precisions, and F1 score. Implementation setup. As I have said, we're going to make use of this data sets of Pavia University, and weebly database repositories. And these image classifications models like logistic regression model, SVM and decision tree model, which we help to get our accuracy, precisions, and F1 scores. And we can normalize with data preprocessing, and hyperspectral images are normalized along with data preprocessing. Confusion matrix is of deeply fully connected neural network is shown here. Confusion matrix is used when we want to know about the performance and overall working of this model. And there is a bar graph of showing how the performances of different existing classifiers and what's a proposed deep fully connected neural network. See, when the precision comparing to precision, log regression model is very low comparing to decision tree and SVM model. But whatever we have proposed of deep fully connected neural network, we're going to achieve higher precision, as well as recall, F1 score, and accuracy. Finally, we can see that there is a pretty drastic differences in accuracy found by log regression, decision tree, SVM model, and whatever we proposed of deep fully connected neural network. This paper, what I'm going to say at final is, this paper tries for the classification of image processing on hyperspectral images. It proposed three dense layered deep fully convected neural network. And this project is implemented with Python language under NVIDIA Tesla V100 GPU server with training echoes of 1000 and batch size of 32. Implementation results show that the proposed fully connected neural network show 95% accuracy comparing to the existing SVM models or decision tree models or log regression models. Thank you.